Hello everybody, sorry for the delay. This is charge your device with the latest malware. And who am I? I'm a researcher in the CRACS Institute, that's Center for Research on Advanced Computing in Portugal. Also I'm a member of C3P, that's a center for focus on web security and information security inside the university as well. And a bit of introduction about the subject. There's needless to ask how many of you have Android. We see a trend over the years. A lot of people have it. Much of that is because of the critical features that it has, like for example the phone banking and email, GPS, web browsing. But we should focus on how that is also exposing us as users ever more, our information over the internet. Such critical tasks should not come with such a trade-off, and that's why we need to research those vulnerabilities. Android vendor customization is good. It is good because this is one of the principal benefits of Android. Android releases versions through the Android Open Source Alliance, which then later the vendors adapt it and release it, adding their own software and customizations. But it is bad because that adds another layer of software that can have breaches as well, and it extends the attack surface of the Android in this case. According to a recent survey, 60% of the vulnerabilities come from the vendor's customization. There's also, this attack is focused on the USB channel. It is often overlooked by security experts, and a good proof of that was the attack Stuxnet, one of the most notorious attacks over the history of attacks, and it was very successful in its endeavor, spreading through USB pen drives. Now let's look at the vulnerabilities on the USB channel. First, there's ADB enabled. If you guys ever programmed in Android, you know ADB. And of course, it is very dangerous because with ADB, you can access the logging system, the logcat. You also can install applications without any signature on the central authority. And it's estimated that 20% of the users have this enabled as default. Now the AT commands. AT is a standard language to communicate with the modem. Protocols such as 3G and GSM adopted it. With the possibility of issuing these commands, we can send the SMS and issue calls. The vulnerability lies that some of the... let's first understand a bit of the AT commands and the modern smartphone. The modern smartphone is divided in two processors. The application processor, that's where your Android is running, and the baseband processor, it's where the operating system on the modem is running, that deals with all the communications and such. So between these two processors, they communicate each other with the AT commands. That's a standard language. That's the preferred way to communicate. Here we see the radio interface layer. That's the abstract layer in the Android framework that deals with this communication and provides a layer for communication with the baseband. Everything you do, like sending SMS and making calls, passes through this layer, and this is established the communication. Here we see the life cycle of a call. First, the application itself, the phone application dials, and then the real intercepts it and talks with the real implementation that talks with the baseband. That's when it talks to the baseband, it translates the commands to AT commands, and then asynchronously responds to the application. The vulnerability is here, the AT commands over the USB. Some vendors, like Samsung and HTC enable this feature so that you can communicate with the modem through the USB. I don't know if you ever noticed plugging a smartphone on your computer, you notice that a virtual modem is connected in the devices on your computer. It poses a risk in the USB connection. Also, there's the Samsung AT proprietary command, not just Samsung, but a lot of vendors add to this layer proprietary commands that enables their applications to do what they want to do. For example, in key software, they obtain the contact files, they update the firmware over, and they use this command and that interface to do that. So with that, and using eavesdrop mechanisms, we notice that key software, this is a eavesdrop communication on the USB channel. This is, for example, the command to obtain the contacts lying in the SIM card. And this is the first ever command issued by the key software to the device. This command returns a lot of information about the email of the smartphone and a lot of other, like the version, a lot of other relevant stuff about the phone that it is here. It also wants the external storage. As you see, when it issues, this storage gets mounted. and it returns all that information. And here is another command issued by keys. That really is the crux of the attack that I'm going to talk later. With this, we are able to place the device in download mode. If you guys know, it's the mode standard for issuing partitions to the device and updating the firmware this way. Sorry. Together, this is an attack scenario that we developed. To use those commands, we mount, like when you see in the airport, there's a lot of charging stations, and people are in a rush to, excuse me. Yeah, maybe I should get a bit of water while I'm talking. And people are in a state of emergency because they want to contact their family upon arrival or upon embarking. And they're never going to think about, is it trustable to charge here or not? They are in a state of emergency. That's just a very plausible scenario. And in there, we can mount a system that instead of charging, it will actually flash a compromised boot, for example, or other attack that we develop. This is the implementation. Here, we focus on the two operating systems by virtual machine, the guest being Ubuntu and the host being Windows 7. Why we use it this way? Because with Ubuntu, we are able to deal with the libUSB libraries like libUSB that is easy to make full automated attacks over the USB. And with the host being Windows 7, we use that because with that we can use the drivers for using the flashing tools like Odin or Heimdall. But we in this case use Odin. This is the architecture. The Ubuntu is responsible for detecting the USB device, for identifying the type of device, actually communicating with the host, that's the Windows. When the Odin, flashing Odin is necessary, it is also responsible for copying the data over that is in the SD card, for example, when issuing the command IT defcon info. Windows 7 is responsible for communicating with the guest, identifying the flash image that is supposed to flash the device, because each device will have its flash, each boot partition. Identify the correct version of Odin, because a lot of different devices will need different kinds of Odin software. There's different, I'm sorry. Different protocols upon flashing. And uses GUI automation tools for things like using the Odin. Odin is only interfaces bigraphical. This is the architecture. The master can relinquish the control of the USB device to the guest when it wants. So you can interchange the control, and when you want to flash, you give it to the master. When you want to be identified, you give it to the guest. And having an AT command interface, what can we do? Having the standard commands, we can send SMS, for example, to a added cost number and earn money or steal money. And yeah, thank you. And for example, steal money off the user with the standard commands. With the AT first command, that's the crux really of the attack, what can we do? First, there's two stages. The pre-attack, where we select the boot partitions and the versions of the phones we want to flash. First, we have to collect a normal boot partition, unpack it, add the malicious code, pack it again, and when attacking, install that boot partition by the AT first command. This is the structure of the boot partition. You see on the left, it is divided by the RAM disk and the kernel. How are we going to change this? We are going to pick the RAM disk. That's the first ever partition ever boot that has a lot of files important for the for the booting of the system. In it, we have the init file. That's standard file for the init file that is responsible for executing necessary functions to the system to boot, and the init RC file. In that file, we have shell script commands that configure the system. And with that, with the malicious boot partitions, we want to mainly obtain three things. That's make always ADB always enabled. We want to gain root access and install an uninstallable surveillance application. Really sorry. In order to make the ADB always enabled, in the init RC file, we see that line, that property line, signifies when the user disables ADB. What we did, we erased the stop ADBD diamond, it's the diamond, and we instead of stop, it starts again. So whatever you do, it will start again, no matter. So you can't disable it. For gaining root access, we use the subinary, that's a standard for gaining root access, with the correct permissions, like that one that sets the set to ID, user ID, making anyone that runs that file to have a root access. For that, we have to make the owner the root. And also install an uninstallable application. What that means is we copy the application to the system apps, making what that does is upon booting, if there's an application to be installed there, it will install as a system application and with system privilege. With that, the user can't remove it. Even if it has root access, the main problem is that upon boot again, it will install again. So really, there's no chance unless he removes the boot partition to the correct one. And it makes it a surveillance because we add that thing to the manifest file, making it a launcher application, and it will not appear the icon on the apps. For that, we use AndroRat, is a already pre-made application that's available on the web. We tested antivirus to see what they did. Mainly, only AVG detected that AndroRat was installed heuristically, but this just shows that these applications in the market are very limited. They have the permissions that standard applications have, and makes it very limited to actually detect it, even remove it. So that just shows us a ways to have that applications on the market. I have a demo here, not a live demo, but I have a video, for example. This is making a call. Maybe I should put in the beginning. Imagine this in an airport, and it's making a call to other cost number. In this case, I'm calling to myself. And here I have to actually flash a new boot partition. You see here, it connects. It's a bit slow, but so imagine this in an airport or any other place. Now it's in download mode, and it takes a bit to install. Maybe the phone is a bit old. You see, just by plugging it, it instantly entered the download mode. Well, it's very, very slow. No, I think not. It is visible, but for now, I think there's no way to hide this screen. This is a standard way to actually update the phone. It will if the user is there. Of course it will, but there's no other way to update the boot and have that root access, at least that I know, by this attack. Of course, if you guys know any other way. Where is the presentation? Okay. To conclude, USB connection should be a thread, and it is a thread that should not be overlooked. The user should be held responsible because to charge the smartphone on locations. Support for AT commands is a good thing over the USB, but those kinds of support also come with a disadvantage that you saw here. So that's it. All the demos here. Questions? Yes, Mr. Shamir.
A suggestion for a startup: you can sell devices that will fit between the telephone and the USB cable that you.
There's a thing that
will stop the communication, but still provide power.
Yes, there's a thing called USB condoms that does exactly that. It cuts the data cable and just leaves but nobody buys it. So awareness is also necessary for people. I'm not selling them, but
Should I just sell it here?
yeah, maybe.
Is that problem only Samsung specific?
We only search on Samsung. That's the devices we had. We also tried the HTC, and HTC has the standard AT commands, but we couldn't find the proprietary.
Other Samsung devices, are they powerful as well?
Yes, there's, for example, the S3 Samsung. That's the latest that we could test, and among others. Nope. Yes, there's more. Installing additional software, for example, if you have if your phone is rooted, there's the process that are specific for handling these kind of commands, and you could just kill it, those process, and there's no problem there. You could install like a Cyanogen mod that has not this interface for communication. Those examples. You could also make the phone only install partitions that are signed by the vendor. Maybe only with the phone rooted that they could really harm the phone security. Only with an application that has above average permissions that they could actually prevent these kinds of attacks that go over the normal permissions. Yes?
So if you go to Starbucks or other places in the US, there is wireless charging. So you put the phone on the net and charges. Is there any way to use wireless charging in order to send any data or to attack? Or is it pure power supply?
I guess it is pure, but I'm not entirely sure how that works, so I can't really comment much. Sir, in the back? Yeah, that makes it more scary to lock the phone in the airport. That's a lot more scary. So in that case, people leave the phone, actually leave the phone, they charge it and leave the phone there. They put the pin. Yes, yes. Yes, I've been. I guess I don't know about that. I don't know about that. Okay, so it's all. Thank you.